Section 2D, Special Product Polynomials. So here we're multiplying a binomial times a binomial, or a binomial times a trinomial, or even a trinomial times a trinomial, etc. We can square a binomial. These are special situations. There are some shortcuts if you can notice them, but I'm not going to show them specifically to you, but I am just going to show you how to distribute. When we have one term being multiplied through a polynomial, it's pretty straightforward. When we have a binomial times a binomial, there are two things that need to be distributed, and then you're considered finished. So, in other words, the negative r times 4r is negative 4r squared. Negative r times negative 2 is a positive 2r. If I distribute the 7 through, then I get a plus 28r and then a minus 14. You look at these and you see if there are any like terms. There are no other r squared, but there are two different r terms, 2r and plus 28r, so plus 30r minus 14. And this would be considered in standard form and simplified. If we try another one, if we go to number 42, this one we have to be very careful with. Many would want to distribute that power, but remember, you can only distribute a power into a parentheses if it's a monomial. This is a binomial, so this means there are two of them. So it's best to write them out officially as two different binomials, or the same binomial written twice, and go through the process that you did before. And that will give us 25 minus 25x. Distribute the second term, and we get minus 25x plus 25x squared when we multiply the last two. These two are like terms, so we're left with 25 minus 50x plus 25x squared. Not in standard form, but at this point it's acceptable because they don't tell us to write it in standard form. If we try another one, and again if we notice the nuances here, number 48 looks similar. Two binomials being multiplied, but if you look closely, they're both exactly the same except one is addition, one is subtraction. So this brings up something interesting. If I go ahead and distribute, I get 9x squared minus 12x, multiply the 4 through, and I get plus 12x minus 16. Now, when you have exactly the same binomial written twice, but change the signs from addition to subtraction, then what happens is the middle terms cancel out. And you're left with the first term that you get and the last term, and the middle term disappears. And that is the case when we have two binomials that are exactly the same except for addition and subtraction. So that's kind of a little clue, a little shortcut. And that ends this lesson.